Okay, so part A. Got to show that 4 plus 3 root x all squared can be written in this other form, 16 plus k root x plus 9x, where k is a constant, and we've got to find that constant. So we'll start then by writing out 4 plus 3 root x, and we've got to square it. So this expression, if we square it, is identical to, okay, make sure you don't write equals, it's identical to, and it's identical to 4 plus 3 root x multiplied by another 4 plus 3 root x, okay, which in turn is identical to, and we'll expand this out, so we get 4 times 4, 16, 4 times 3 root x, 4 3s are 12, and we get 12 root x. Then we have 3 root x times 4, so that's another 12 root x. And finally, plus 3 root x times another plus 3 root x, in other words, squaring it, gives 3 3s are 9. And root x times root x is just going to be x, which in turn then is identical to 16. Then we have the root x terms we can group up, so we have 12 of them here and another 12, so that's a total of 24 of them, 24 root x. And then finally plus 9x. So you can see that this is identical in pattern structure to what we had to show. That was 16 plus k root x plus 9x, where, as you can see, the k value is 24. So k equals 24. Alright, let's move on to part B now. And in part B, we've got to find the integral of 4 plus 3 root x all squared, and integrate that with respect to x. Well, obviously this is linked to part A because we now have the full expansion of it, so we can say that this is equal to the integral of this expression up here. So we've got 16 plus 24 root x plus 9x, and that's integrated with respect to x. Now, because we've got several terms here, don't forget to put this all in brackets, so we're integrating the whole lot with respect to x. So many times I see people leaving out brackets when you've got more than one term on integrals. Okay, so don't do that. Put your next equals underneath. Okay, and so we look across here and check that we can integrate every term before going forward, and we can integrate the 16, should be able to integrate that, and we should be able to integrate the 9x. So we're ready to integrate. So the integral of 16 is 16x, and when we come to integrating 24 root x, we must think of root x as x to the power half. So when we integrate, we've got the 24, we add 1 to the power of x, so adding 1 to the x to the power half is going to be x to the 1.5. Don't write 1.5, but write it as 3 over 2. Okay, and then we would divide the whole of this by 3 over 2. So I'll write that underneath like that. We'll clean this term up in a few moments. We move on to the next term. Integrating plus 9x gives plus 9, and then we add 1 to the power x, so at the moment it's x to the power 1, so we add 1, that's x to the power 2, and divide by the new power, so that'd be over 2. Don't forget to write plus c in though. That's always forgotten, I find, with quite a lot of students. Plus c for that constant. Okay, next we move on, just to tidy this up. First term looks okay to me, so that's just going to stay as 16x. But this term here doesn't look too good. I could multiply top and bottom by 2, which would give me 24 would become 24 times 2, which is 48. And the bottom here would become just simply 3. So I'd have 48 over 3. And 48 is divisible by 3. It goes in 16 times. So that will give 16 times x to the power 3 over 2. Then the last term, well, that seems okay to me, so we'll just leave it as 9x squared all over 2. And then, as I say, don't forget that constant of integration, plus c. Okay, so that's essentially the answer to that integral. So hope you got that one right.